So we're going to do one more of these mixture problems. This is problem 42. And so let's go and make our table up. 4x3 table. First column is going to be the strength. Second column is liters of solution. Liters, I guess I should put an S of, what do we have in this one? Some chemical solution. Chemical, say. Whatever that is. Okay, it says a tank holds 80 liters of a chemical solution. Currently the solution has a strength of 30%. How much of this should be drained and replaced with a 70% solution to get a final strength of 40%? Okay, so the total, this is the total mixture, and since the tank is 80 liters, that's going to go in this third row. And we want the final solution to be 40%, which is equivalent to 0.4 decimal equivalent. Now initially, we have 80 liters, well we have total 80 liters, so we have the lower strength solution, which is 30%, which is decimal equivalent to 0.3, and then we have the higher 70%, which is decimal equivalent to 0.7. So you can see that 40 is between 30 and 70. Just like in the previous example, the number of liters of the thinner solution is going to be 80 minus X, because we're going to drain X and we're going to replace X with the stronger stuff, and the stuff we drain is going to have to drain enough so when you add this plus that you get this plus that you get back to the 80 in the tank. So then we do our multiplications in this direction. So we have the strength times the number of liters. Strength times the number of liters. And the strength, so this plus this times that has to equal the sum, because they have the original dilute solution, and we add those together, and you have to end up with the total number of liters of the chemical. So we add down this way. So you get 0.3 times 80 minus X plus 0.7X. And then the final part is you take this times that has to equal that. And that's where we define, or we determine X. So we have 40%, 80 liters at 40% has to equal 0.3 times 80 minus X plus 0.7 times X. Okay, we multiplied by 10 to get rid of these decimals. So this becomes 4. This will become 3. And this will become 7. So everything has a decimal point moved 1 point to the right. Okay. Now once we got rid of the decimal points, we multiply things out. So 4 times 800, 4 times 80 is 320. 3 times 80 is 240. 3 times negative X is negative 3X. And then we bring the 7 down. Okay. Then we combine like terms. So the only ones we have to worry about are these two. And 7 minus 3 is 4, or negative 3 plus 7 is 4. It's negative 4X. Need to subtract 240 from both sides to get all of the constants on the left-hand side, on one side. So this goes to 0. This is 4x plus 0x is just 4x. 320 minus 240 is 80. Divide both sides by coefficient in front of x. You get x equals 20. So that's 20 liters So we're going to drain off 28 liters, which will leave 60 liters left. 60 liters at 30% solution plus 20 liters at 70% solution. 60 plus 20 gives you 80 liters of solution, and the final percent strength will be 40%. How do we know that? Let's just so if I take 0.3 times 80 minus x, which is 20, plus 0.7 times 20. So I'm just substituting 20 in there. Actually, what that's going to do is just give me the liters of the chemical. So let's just do that. So that's going to be 60 times 0.3, which is going to be 18 plus 0.7 times that. That's going to be 14. So you get 32 liters. 32 liters of the chemical. And you have 80 liters of the solution. So if you take 32 liters of the chemical divided by 80 liters of the solution, you'll get 0.4 or 40%, which is what we're supposed to get. Okay, so we're going to move on to the next kind of problems, which are money problems. And it's similar if you look at page 303, problem 46. You'll see it's kind of the same situation. Instead of solutions, it's investments, different investment decisions. So let's set up this, and it's same size table. So you've got rate, which is the rate return, meaning how much interest you get. Then you have the total amount, and then you have the interest here. So the principal is the amount of money that you have in the different kinds of investments. The rate of return is how much of what percentage of that principal you get due to that investment. The interest is the amount of money that you get. So this is the rate. The interest is principal times rate. Just like over here, the number of liters of chemical is equal to the number of liters solutions times the percent solution. So they've got this filled in here. You got something with 2%, which is kind of low, but not crazy. And the principal is, in this investment, is X. What you basically have is you have $60,000 to invest. So you're going to, if you invest X in one type of return, then what's going to be left over is the rest of it. So that goes in the other account. So if you have $60,000 and you put $20,000 in here, you're going to have $40,000 left to put in the other one. So that's the first. So the principal, the total principal is $60,000. So if we assign X as being one of the questions, how much do I put in this smaller account? The rest has to be 60 minus X, so you add them together and you get 60,000. So that's my total principal. Now they don't fill that in the table, but so interest is rate of return times principal. So just same kind of deal. You multiply the decimal. This is 2% in 2%, which is equivalent decimal equivalent of 0.02. So you take this times that. Okay, so let's read it now. Kim Hobbs won $60,000, so she wants to do something with it. She invests part of it, X, in at 2%, and the rest at 3%. So the rest is this much. So that's the rate of return, 0.03. She earned a total of $1,600. So this is interest is how much she earned. The question is, what is X? Well, again, this times that is that. Same here. This times that has to be that. And so the total interest is this plus that. It has to equal that. The larger I put in the smaller account, the less money I make. If I put it all in the higher account, then I make the most money. So why would you do this? Well, these may be the expected rate of returns. We don't know for sure. This one might be more predictable, and this one's less predictable. That would be why we would split it up. Okay, continuing on. You're like, what are you talking about? Yeah, I had to go to a meeting. So, see, where was I? So what we had is $60,000. We were going to put a certain amount, X, into one fund and the rest of it into another fund. The rate of return of the lower return fund was 2% or 0.02, and the rate of return of the higher yield fund was 0.03. And we filled in the table, and we're just at the point where we have to come up with our equation. So instead of going this way, we go this way, because this is the amount of interest I make from this investment, this is the amount of interest I make from this investment, and those have to add up to the total amount that I got. So we take 0.02x, which is this. We add the amount we get from the second investment, and that ends up having to be $1,600. So now we have our algebraic equation, and we just have to first multiply by 100. So that we can rewrite this in terms of whole numbers instead of decimals. So 1,600 times 100, you add 2 additional zeros to that. So you'll have 600, and then 2 more zeros when you multiply by 100. Now remember that, when I multiply by 100, I only have to multiply one of the things by 100. I can multiply these by 100 and not that. That wouldn't really help me any. So I just multiply the part on the left-hand side, which are hundreds, to get those to be integers. Okay. Now the rest should be pretty easy. 2x plus 3 times 60,000 is 108,000. 3 times negative x is negative 3x. And that's going to be equal to 160,000. Combine like terms, so we'll get negative x plus 180,000 is equal to 160,000. We need to solve for x, so first thing I'm going to do is subtract 180,000 from both sides of the equation. Like this go to 0, so I get negative x is equal to negative 20,000 divided by negative 1. Negative 1 divided by negative 1 is 1. So I get x is $20,000. So that's what this, so that's x, and so 60,000 minus x, just the rest of it is 40,000. So I'm going to put 20,000 in this, 40,000 in this account. Again, if I wanted to get the maximum rate of return, I'd put all the money in 3%. But typically, as we'll see later on in the semester, the higher rate of the return, possible rate of return, the more uncertainty there is. It could be 9%, it could be 3%, it could be negative 3%. So those are the kind of things you have to balance. So did I get this right? Which one is this? 46. 20,000, 2%, 40,000, 3%. So that's correct. So I've got one more to do here. Since I'm doing them in threes. 47. So 47 is like 46, except they don't give you the table. So we're going to go ahead and make the table. So this is rate. This is principal. This is interest. So let's read 47. Derek Nance invested some money at 4.5%. So 4.5% is the same as 0.045. That's the decimal equivalent. Simple interest. That just means we do it the same way we did here. Some money, X. So that's some money. And $1,000 less than twice this amount at 3%. So we're going to have 3%, which is decimal equivalent 0.03. And then so it says $1,000 less than twice this amount. Twice this amount, and it's $1,000 less. So it's $1,000 less is twice as much as the original amount. Okay. His total income from the interest is $1,020. So again, this times that is that, this times that is that, this plus this plus this is that. Pretty simple. So this is going to be 0.045x. This is going to be 0.03 times 2x minus 1,000. This times that is that. And then we say this plus this equals that. And the question is, how much does he put in here? And then this is going to be 2 times that minus 1,000. Okay, so we take 0.045x, this entry, plus 0.03 times 2x minus 1,000. And that's going to be equal to 1,020. So we're going to multiply by 100, actually by 1,000 in this case, because it's 0.45. So if we multiply by 1,000, because we have 1, 2, 3 decimal points. So that's going to be 45x plus 300, no, 30. So this is 1, 2, 3, 1, 2, add a 0 to make 3, so that's that. And then you multiply this times 1,000, which multiplying by 1,000 is adding 3 zeros, 1, 2, 3. So that's adding in. Okay. So we're going to get rid of the parentheses. So 30 times 2x is 60x. 30 times negative 1,000 is negative 30,000. That's equal to 1,020,000. Combine like terms, that's going to be 105x minus 30,000. I'm removing the commas here just because when I do this subtraction, I just want them, I didn't want them confusing me. So we want to solve, we want to get 105x on one side, so we're going to do that. So we get 105x is equal to 105. So you get 102 plus 3 is 105, and then you have 4 zeros. You get 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros. So then you divide both sides by 105. So you get x is equal to, so you can plug that in your calculator, but if you think about it, by dividing by 105, it's like dividing by 100, so you have to move the decimal point 2 places, and then you have to, because it's 105, bottom line is it's 10,000. You just put that in your calculator. So x equals 10,000, and the remainder is 2x minus 1,000. So that's 20,000. X is 10,000. So 2 times 10 is 20. 20,000 minus 1,000 is I get $19,000. So we have 10,000 at 4.5% and 19,000 at 3%. So that's that one.